equal to 1 plus cosine 2x over 2, right? What would happen if I have a cosine squared 2x? 1 plus cosine, why is it a 4x? Bless you. Think this through, guys. If I have an x here, then that means I have an x there. So if I have a 2x here, that means I have a 2x there. 2x times 2 gives you the 4. Yes? That's the reason why. So what would it be if I had cosine squared 3x? 1 plus cosine 6x over 2. Cool? Alright, so now that I know what I need to change it to, kind of wrote all over it, I'm going to go to the side. I have a 1/4 integral of 1 plus cosine 4x over 2 dx. I can pull out a 1/2, right? So that would be a 1/8. Bless you. 1 plus cosine 4x dx, right? Okay, what is the integral of 1? What is the integral of cosine 4x? 1/4, positive or negative? Positive, right? So 1/4 sine 4x plus c, right? Now, let's not get lost. It was that part plus this part right here, right? So final answer, let's see, I have a 1/8 x, right? Which I can combine with this x to the 4th, which would be 3/8, right? So 3/8 x. And then this and this wouldn't combine, right? So plus 1/4 sine 2x plus 1/8 times 1/4 would be 1 over 32 sine 4x plus c. Cool? Alright, questions about sines and cosines? Sure? Okay. I mean, obviously we can practice more, but you can practice the rest of this on the homework. Cool? Now we're ready to move on to secants and tangents. And there are 5 rules for that. So, 5 rules. It's not the best handwriting, but here we go. Okay, so we're dealing with secant and tangent. Number 1, it says that if the power of secant is even and positive, then we're going to save a secant squared and convert the remaining to tangents. The reason why we want to save a secant squared is because of the trigonometric identity, tangent squared plus 1 equals secant squared. You with me? Okay. I'm going to talk about them and I'll let you write them. Number 2 is if the power of tangent is odd and positive, we're going to keep a secant tangent. Now, this is assuming that whatever you're integrating also has secants with it. So if you have something that has secants and then it has a tangent that its power is odd and positive, then you're going to save a secant tangent and convert the remaining to secants. If you don't have any secant factors, in other words, if you only have a power of tangent and the power happens to be even a positive, you will convert the tangent square factor to secant square factors. Number 4, if you only have secants and to a power and that power is odd and positive, you will use integration by parts. And 5, my least favorite of them all, and the one that you wish that doesn't happen, is that if none of the above work, you will turn everything into sines and cosines, and then you will utilize the 3 rules that we started with today. That is the worst case scenario. You do not want to start there just because you feel comfortable with sines and cosines. I know, like, for example, this is comparable to when you were in trig and you were doing proofs of identities. And like most students felt comfortable with sine and cosine, so they started turning everything into sine and cosines, and typically those proofs turned to be a nightmare. That's the equivalent here. You do not want to go to sines and cosines unless you don't have another option. Cool? So I'll go ahead and pause the video, let you write this down, and then we'll continue. Alright, I'm assuming you've written down the rules, so we're ready to try out an example. So, let's do our first example for this. Let's do an integral of secant to the power of 4, 3x, tangent to the power of 3, 3x dx. Okay, so the rules are a little differently this time, right? So go back and read the 5 rules that I provided, and let's see which ones would apply, if any. So the first one applies, right? We have a power of secant being even, right? So we can use that one. Could we use the second? It says the power of tangent is odd, right? So we could use the second one as well. Now you don't want to use them both. You gotta pick one and go with that and see where it takes you, right? The third one doesn't apply, right? There are secant factors. The fourth one doesn't apply because there is a tangent factor. And we said the fifth one we're going to avoid if possible. Yes? So you've got a choice here, and you've got a choice to make. Where do you want to go with this? First one? Okay, so you've chosen the first one, which means that we are going to keep what? One of the secant squares. So we are going to keep one of the secant squares, which means that I have secant squared 3x, secant squared 3x, tangent cubed 3x dx, right? So what are you going to do with the other secant square? Turn it into tangent squared 3x plus 1 in this case, right? So we're going to keep 1. This one becomes tangent squared 3x plus 1 times the tangent cubed 3x dx. Once you do that, the rest of this should start cleaning up pretty nicely. Okay, which means we just have to multiply, just got to do some arithmetic, and things should start looking better. Okay, cool. So what happens when I start multiplying this in? So I've got that times that times that, which becomes what? Secant squared 3x tangent to the 5th power 3x, and then I've got that times that times that, plus secant squared 3x tangent cubed 3x dx, right? So this entire thing dx. Bless you. Do you guys see it? What is u? Tangent, because the derivative of tangent is secant square, and that is the reason why we wanted to keep a secant square. Now you gotta be careful because this one has a 3x, so therefore we need a 1/3. Yes? So that means that the integral for this part is what? I need a 1/3. This would be like saying u to the 5th, so this would be u to the 6th. So tangent to the 6th power 3x over 6, right? Same idea here, right? You've got the exact same thing going on here, except we need a 1/3, right? And this time it's u to the 3rd, so it would be tangent to the 4th 3x over 4 plus c. So final answer, if I clean this up, would be what? Tangent to the 6th power 3x over 18 plus tangent to the 4th power 3x over 12 plus c. Cool? It's not as bad as it seems when you're writing all these rules down, right? It really, if you really narrow these rules down, it's just like, how can we make the problems easy enough to use up? I don't know if you've noticed that was the same thing that happened with integration by parts. Like, how can we still use substitution to solve problems? Bless you. Cool. All right. Questions about this one? All right. So I'm gonna let you try one on your own, and then we're gonna tackle one last one together, and that'll be it for today. So let's take an integral from 0 to pi over 4 of tangent to the 4th power of x dx. So if you're watching the video, go ahead and pause it, give it a shot, and when you're ready to check the answer, hit play. Alright, so for this example, let's just go over it very quickly. I rewrote tangent to the 4th power of x into tangent square x times tangent square x. I turned that tangent square x into secant square x minus 1 and distributed the tangent square so that I could have two separate expressions here. This is a simple u substitution because we know the derivative of tangent is secant squared, so it's a u sub. So this would be u to the 3rd over 3, which gets us to this part. Now this part is where you got to think about it a little bit. Instead of, I don't know, like if you going back and thinking of everything like other rules, you got to remember like tangent square x is the same thing as secant square x minus 1, but because it's a minus here, that makes this into a negative and that into a positive. And that's simple to integrate because the integral of secant square would be tangent, which gives us that, and then the integral of x would be that. Evaluate everything at pi over 4. Hopefully we didn't forget our unit circle. Tangent of pi over 4 is 1 to the 3rd power is 1 divided by 3 is 1/3. Minus 1 gets you this negative 2/3 plus the pi over 4. Tangent of 0, 0, 0, 0. So your final answer would be negative 2/3 plus pi over 4. Cool? All right. Any questions about that one? Okay, the last one I want to tackle with you guys would be what if we do like a secant by itself? And let's do a secant to the 3rd power x dx. Cool? So, according to the rules, what do we try? It says integration by parts. But the way you attack this problem, I like that the rule helps you, but it's not very helpful. It doesn't really break it down for you. You're first of all going to rewrite this as secant square x secant x dx. You guys with me? Okay. Now this is where things get interesting because it says we're going to tackle this by integration by parts. But if you realize, according to Liotte, they're both at the same level. They're both trig. So which one's u? And the question then would be, which one is easier to integrate? The secant square. Therefore, we're going to let u be the other thing. You with me? So we're going to say u is secant x, which means that dv is secant square x dx, which means that du is secant x tangent x dx, and then v would be tangent of x. Agreed? So according to integration by parts, we're going to say then that the integral of secant cube x dx is equal to u times v, which is secant tangent, minus this times that, right? So the integral of what? What do we got? Secant x tangent square x dx. Right? And now what? We're going to go back to our rules. What do we got? So you want to turn this into secant square minus 1? But then what? Because if we turn that into secant square minus 1, right, wouldn't that turn into then secant cubed minus secant? And then what's the integral of secant cubed? Aren't we then back to that? Right?